Okay, so this is a nice exponential equation here. Usually when you have x in a exponent, you think about logging both sides, because then that might bring the exponent down to the start. The problem here is if I take log, maybe log base 2, if I take log base 2 of the left hand side, just get rid of that a bit there, and I take log to the base 2 of the right hand side, the problem here is that these two terms are separated by an addition. We cannot unpack an addition here. We can only unpack a product within a bracket there. So logging both sides really doesn't help here. In other situations, if the 8 wasn't there, then logging both sides would help, because you see then the exponents could come down to the front. We can make some kind of progress. But it's because of that plus 8 there, makes it a little bit harder. So really the idea of having a plus 8 here changes the attack needed for this question, and the attack usually is a hidden quadratic. So let's just follow it through. Because we've got a 4 and a 2, maybe we just change to the simplest base. This is 2 squared, and this is 2 to the x plus 8. We're going to expand. I'm going to bring this across. And we're just going to play with this a little bit. This is 2 to the negative 2 times 2 to the x times by 2. Just have to take a moment to look at what I've done there with the exponents. Convince yourself that this here, just undo that, I actually wanted this guy here. Convince yourself that this is equivalent to this. If you're not too sure, just pause the video and go over that again. And then here, this is actually 1 over 4, and this is 2 to the x squared. You might be able to see the quadratic being formed. If I multiply everything by 4 here, this is 2 to the x squared minus 4 times 2 to the x minus 32 equals 0. Now if you're still unsure where the quadratic is, there's one final trick we can do, and we can do a substitution. Let 2 to the x equal to y, and then can you see we've got y squared minus 4y minus 4y equals 0, and now you can probably see the quadratic. So let's go ahead and solve in y. Factorize. 8 times 4 gives 32, 1 negative, 1 positive, therefore y equals negative 4, or y equals 8, and then change it back into the exponential format. Y represented 2 to the x, so 2 to the x equals negative 4. There's obviously no solution to this. Or 2 to the x equals to 8, therefore x equals to 3. Finally, just check that 3 would indeed work in the original equation. Can I substitute a 3 in here? The answer is yes. Can I substitute a 3 in here? The answer is yes. And if you went ahead and worked that out, you'd indeed get 16 balances with 16. So that's a classic hidden quadratic with exponentials. It's typically a level 7 on our syllabus, SLAA.